Three cylinders, each with a radius 10 centimeters, are stacked and held together with a red strap as shown in the diagram. Calculate the area of the orange shaded region, which is that area there, and the length of the red strap used. Okay, obviously what you need is a diagram, and what we're going to do first of all is mark on the centre of each circle, roughly, and then draw in a equilateral triangle. We know it's equilateral because we know each of those lengths are the same, and we're going to give them the letters P, Q, R. We know that this is 10 centimetres. We know this is 10 centimetres because we're told the radius of the circle is 10 centimetres, and therefore this one is also 10 centimetres. These two are also 10 centimetres, and these two are also 10 centimetres. So one side of the triangle is 20 centimetres. Right, we know this angle is 60 degrees, but we're working in radians, so it's pi over 3, so you need to know what 60 degrees is in radians. And so therefore the other three angles are also pi over 3 because the triangle is equilateral. Right, so the area of the shaded region, orange shaded region, this bit here, is going to be the area of this triangle minus the area of, now if you take one of these sectors, this sector and this sector are the same, so you need to do 3 times the area of this sector, which has been highlighted here. Okay, so the area is going to be, now if we use a half PQ sine R, so if this is angle P, this is called small p. If this is angle Q, this is called small q, and if this is angle R, this is called small r. Then the area can be found by doing a half of P times Q times the sine of R. So that would be a half times 20 squared, it's 20 because the length of this is 20, so 20 times the sine of pi by 3, minus the area of a sector. Now the area of a sector, when the angle is measured in radians, it's important the angle is measured in radians, is a half r squared theta. So we've got, and there's 3 of those, so it's going to be a half of times 10 squared times pi, because the radius of one of the circles is 10. Right, working that out on your calculator, you get 16.125, and rounding off to 3 significant figures, that becomes 16.1 centimetres squared to 3 significant figures. Okay, now to find the length of the strap all the way round. So again, go into a diagram. Again, I'm going to put those centre points line and draw that triangle up. Now, if I draw that line in here, now this part here is actually a tangent to the circle. This is the radius. Therefore, we know that that angle is 90 degrees, and therefore that one is also 90. That one's 90, and that one's 90. And we know that the length here is 20, this is 20, and this is 20. What we've got to do is find one of these arc lengths and multiply it by 3. So if we call this angle pi by 3, this angle here is also 90, and this angle here is also 90. And therefore we can find this angle here by doing 2 pi, which is 360 degrees, minus pi by 2, which is 90, minus pi by 3, minus pi by 2, and we're going to get that this angle is 2 pi by 3. So it's actually 1/3 of the circle, which is 120 degrees, if you want to think of it in degrees. So the length of the strap will be 3 times 20, there's 3 of these, times 3 times this arc length. It appears 3 times, once here, and once here. So now that's going to be 3 times 20. Now if you want to find arc length when the angle is measured in radians, it's r times theta. So it's going to be 3 times 20 plus 10 times 2 pi by 3. The radius here is 10. And then that on your calculator gives you 122.831, which gives you 123 centimetres. Is that 8 will make that 2 or 3 to 3 significant figures. Okay, so this has been an example of problem solving using radian measure. I hope you've understood, and I thank you very much for watching.